Hi, kids. Okay. Hey, I'm gonna show you guys how we can go from one graph to another using slope or area. So first of all, let's just make sure you guys, again, I want to remind you, we're not memorizing here, we're understanding. But if we take a look at this, if I say, hey, I have a displacement versus time graph. Sorry, there's a little bit of glare. But if I have a displacement versus time graph, and I want to go to a velocity versus time graph. Well, displacement meters, this is seconds, so I rise over run, meters per second. So to go this way, I need to look at the slope. Okay, duh. Okay. Well, if I have meters per second and I have seconds, well, meters per second, what is that? Oh yeah, that's going to be that would be my acceleration. So hey, guess what? If I want to go from here to here to here to here, I'm going to look at the slope. Okay. Well, guess what? To go this way, okay, I need to look at the area. Okay. Because again, meters per second times seconds, meters per second. Meters per second times seconds, meters. Okay. So this way slope, this way area. But again, don't memorize it, understand it, think about it, have it make sense to you. Okay. But if we had a question where it's like something like this, and because sometimes it's a little more mathematical, if I have this velocity graph, first of all, if I want to describe this velocity motion, I start negative, so I'm moving backwards. I'm going towards zero, so I'm moving backwards, slowing down. I stop for an instant, and then I am moving forward, speeding up, and then I'm moving forward at a constant speed, if you wanted to describe it. But then if you wanted to actually draw out your x versus t and your a versus t graphs, we could do that, and it would look something like this. So if I want to draw out my x versus t graph, first of all you would go, all right, so if you look, okay, I'm moving backwards, slowing down. So how do I show that? Moving backwards, negative slope, slowing down. So that means I have to be getting less steep, so that if I decided I'm going to start here, because you can start wherever you want, moving backwards, slowing down, okay, I stop for an instant. So if I'm going to stop, I have to have a horizontal tangent line, and then I'm going to speed up going forward, and then I'm going to go forward at a constant speed. Okay, so that would be, hopefully that makes sense. If there's questions that said, hey, at, let's say, 4 seconds, what is your displacement? Well, how would you do that? You would have to look at the area. So I'd have to find the area of this piece. The area of that piece right there, that little triangle, would be base times height times 1/2. So that would be -2 meters. So here's what that means. From 0 to 2 meters, after that 2 seconds, after 2 seconds, I have gone 2 meters backwards. So here's my starting point. I have gone 2 meters backwards. So if this is +4, that means this would be +2. Hopefully that makes sense. Okay. Then this piece is +2. So guess what? I'm going to walk 2 meters forward. So I walk 2 meters backwards. I walk 2 meters forwards. And I am back at my starting point right here. And then I am going to do for this piece, it's going to be 2 times 2, so that'd be +4. So then I would walk 4 more meters forward. Okay? So hopefully that makes sense. If I wanted to make an a versus t graph, okay, I'm going to look at my slope. And if I look at my slope, well, my slope is positive, it's constant. In fact, what is my slope? Well, this is, right, rise is 2, my run is 2, it's 1. So for the first 3 seconds, my slope would be +1 meter per second squared. And then for that, my slope would be 0. There you go.
Bye, kids!